And then we will begin. We start sharing and get some of the things done that we need to get done. When that comes through. All right, done. First things first, let's do the code so that people who watch this later note. This code is just going to be a reminder that tomorrow is semester test 1. That's it. Semester test 1. That's the code. Tomorrow is semester test 1. Remember that. Don't forget it. Semester test 1. That's what's happening tomorrow. ST1. The code for anyone who's filling this in on the link for late attendance in the YouTube description, not on Blackboard. Okay, that's first things first. Then over the weekend, there was an issue with the VPL execution server, not the main user interface. It was fine. So all of your code is still there, and you could have still worked on the things on code blocks until the VPL server was fixed this morning. We did correct the problem and reboot it. Hopefully it doesn't happen again. I think I've taken steps that will prevent what happened from reoccurring. But as you know, with software, sometimes you can never be 100% sure. So we will just do our best. Then, also very importantly, so the semester is tomorrow, but the honesty declaration is already online. So you should sign it. So you can just type in your answers. You don't have to print it out and sign it or anything like that. Or you could use some like PDF editors, more fancy signature things if you really want to, and then upload it before the deadline tomorrow, which will be the beginning of the test. If you do that, you get bonus marks. Not bonus test marks. They count in the practical pool, but still bonus marks are bonus marks. So please follow through with that. And they'll be closed. It'll be closed during the test, the honesty declaration upload, and reopened after the test ends. So if you upload after the test, you don't get the bonus marks, but you have to upload the honesty declaration. Otherwise, we may not mark your paper. So please definitely make sure that you do that. Of course, the test takes place on Eve. You'll upload a document to Eve, either PDF or PDF document, but you can create it in Word if you want, or if you do want to write everything down and use Cam Scanner to scan it, please do so. You've been given several emails, including instructions for various things that can help you do things like that. So that's that. So in terms of diagrams and things like that, you can hand draw them and scan them. We don't mind, as long as they come up in the document. We're happy. And that your diagrams don't have to be the neatest, they just have to be readable. So even if you do it like on Dia or something and it's a bit of a mess, but we can still see what's going on, that's fine. Don't waste time making it the most beautiful work of art in the world. Yeah, that's fine. Perfect. Just if you just type your name, that's fine. Just put your surname, that's fine. Initials maybe not that great. I'd rather it were your name properly. I think technically even something like an X is acceptable because of whatever, but let's not go there. Let's just write our names, then we'll be happy. Okay, so it's a good question about writing C++ code. Those are what we call cold coding tests, and they don't really work when you have access to a compiler or anything like that. So you won't get a question like that. What's going to happen is that your question 1, the number conversion question, is worth more, and your fill in the code, fill in the blanks question is also worth more. That being said, very, very importantly about question 1, that's the number conversion question, right? As well as anything else in the numeracy that's applied. So that could include things like negative number representation or any of the other things we discussed under numeracy. Those you need to show working out because obviously it's an applied question, but we need to know that you did it. So you either show the working out step by step, or you include the conversion table with your submission, or something that shows us that you did the work. So will there be, yeah, so there's only 4 questions now. It's not 5 questions. And then those 10 marks from the last question have been distributed between question 1 and question 2. So those are now worth more. So question 5 was removed. So just include it in the document, just as part of your submission. So you can just include it before you start question 1. Just show the document with the conversion table, and we're good to go. So please do that. They're very easy to generate. There's lots of videos. I can't do it now because we've got work to do. We have to keep going with this. So please watch some of the tutorials where I go through past papers. I always generate that document, that conversion table. You just need to include that as well, and then you can include it right there. I would say answering in Word is an easy way to do it. Word would be perfectly fine. So go for it. Word is great. Because you can always embed your images for your design, not your design, your circuit diagram, and you do UML as well into the Word document. So please do that. So we prefer you to submit a PDF, but remember, if you've got a Word document, these days it's trivial to save to PDF. So you can save as, not going to open the semester test 1 for you, but you can save somewhere else. So save as PDF, and you're done. Don't name it Doc1. You name it, let's say, you know, the exact format is in the instructions, but you know, including your student number and so on, but give it the name according to the instructions, similar to how you've been naming your practicals, and then you're good to go. So save as PDF, please. You can answer a paper, use something like Cam Scanner to scan it to PDF and then submit that. You have an hour after the end of the test to combine your PDFs and do whatever it is that you need to do, paste in your images, save to PDF, all of that busy work required to get your final answer. So there's enough time, but obviously you can't keep writing after that. So, you know, we're not going to be sympathetic if you say, oh, I ran out of time to answer the questions, because you had literally, you know, the full amount of time, maximum, you know, the full period, and then you had extra time to create your submission and do all the bureaucratic stuff necessary to upload. So there's plenty of time to upload, but you must use it. You can't just run up to the next deadline and then miss it. You have to use that to upload. So thank you. Oh, that time to upload. So you upload to Eve, it'll be under practicals. So yeah, it's 40 minutes to actually write the paper, and then 1 hour after 40 minutes. So if I have my thing here, so we got class over there. Class ends at 5 past 5. So the submissions should close then at 5 past 6. So you have that whole time, and 5 past 6 it will close, and then you will and then it's closed. So please make use of that time. Great question. That's the next thing I was going to get to. There will be a tutorial, but not a live one. It will be a pre-recorded tutorial. The other tutorials throughout the week will be regular live tutorials. So if you do want that sort of experience, please go to those tutorials. Also, there will be a Saturday tutorial as well. But the content for this will be made available, but as a pre-recorded tutorial, and then variants of it in live formats throughout the week if you do want that. So that actually is the last thing I wanted to talk about. So thank you very much for bringing it up. And then I think we can continue. Cool. All right. Just needed to get all of that information out there. Now, what's the time now? Yes, we got until 7:30. Okay. So, all right. So that's fine. Let's continue. Let's go. So we were. No, that's not what I wanted. Yes, that's right. This is what I wanted. We were busy with functions. And this last bit of functions is advanced stuff. You get the you'll never have to do this in the second semester test or exam, but there are bonus marks for using some of the more modern C++ techniques that we do show you. So it's not worth anything, but it's not a requirement. So if you struggle with these concepts, and they are fairly sophisticated concepts for new programmers, that's fine. Don't worry about it. It's bonus marks. They're not too difficult, but they're not required. So it is purely extra. Right, so C++11, the standard, was sort of a boundary between sort of traditional C++ and what they consider the era of modern C++. We still do a lot of traditional C++ stuff in this course because it's good for learning the fundamentals, but you'll see an actual production code in the wild. They typically now, for new projects, try to program more in the modern C++11 and afterwards style. So C++11 was a major change to the standard. It was the first change. So it came out in 2011, and then the last standard change before that was 1998, with a small revision in 2003. So there's a huge gap in time before that revision came out. And there's since been subsequent revisions. There was another one in 14 and 17, and now in 2020. But those have been much smaller changes, adding a few new features here and a few nice things there, but nothing majorly complicated. So that's the big boundary. So anonymous functions are something that came in modern C++. A lot of programming languages support them, Javas and pure functional programming languages. And they're typically called lambdas in those languages based on lambda calculus, which is a kind of mathematics. If you are interested in learning about it, I do teach it at the honors level in functional programming. It's literally actually the class that happens after your class now. So that's why they're called that, and they're useful, but you don't have to use them. It basically lets you create a very small function without a name inside the scope of something else, like inside a loop or inside another function that you can then use locally very quickly to do something, and there's no point in giving it a name, basically. It's got a weird syntax. It definitely looks strange if you're not used to it. It starts off with a set of square brackets, which basically says, now, here's the strange thing about these lambdas, is that they can actually reach outside of themselves and touch the contents of local variables in the scope that they're in. Those are called variables that have been captured. So by default, they don't capture anything, and you can just treat them like a normal function. But if you want to, you can let them capture everything for reading only, or capture everything for reading and writing, or you can specify specific variables that you want them to have access to, either for reading, writing, or both. Like any function, it has a parameter list. Some people tend not to use them because you can get information into them through the capture list. Others treat them just as regular functions with long parameter lists. That's specific to the programmer and the style that they're following. Things like, there's an additional keyword called mutable, which basically says, as a blanket rule, whether or not the variables that have been captured can be changed. There's another keyword called noExcept, which really won't make sense until the second semester when you've done exception handling. Sometimes you use them to give back answers. Like any function, you can have a return type, and it's in that postfix notation we discussed. So this postfix notation we mentioned way back here as an optional extra somewhere, was introduced so that the normal functions could look like the lambda functions and everything could be consistent if you wanted them to be. So that's why it appeared at the same time as these lambda functions. But lambda functions are always in this style. Okay, and then it's got a body like any other function between a pair of braces. So here's an example of a lambda. I format my lambdas so that they really look like normal functions. Some people write them in one line and they're almost impossible to read, but I always make a point of making sure that the braces line up. And it basically looks, if you look at it now, like a weird function whose name is square brackets and is in the postfix notation returning bool. And other than that, it looks like a regular function. Except that it doesn't have a name, making it anonymous. So I tend to write them in that style. Kind of defeats the point of having a very short thing, but does make it more readable. So that's what I always do. If you want to be super weird, you can actually assign the value of a lambda expression to a variable, and then you can use that variable as though it were a function. So you can store a function in a variable if that is something you want to do. The actual type of this variable will be something in the there's the functional library type, and there are various types within that library for storing functions with particular parameter lists and return types. In fact, it's completely flexible. You can specify what the parameter lists and return types are when you use the type, but it's very messy and awkward. So most of the time, you just let the compiler figure it out. Remember, we did discuss the auto, the modern C++ keyword that lets C++ figure out what the type of something should be. So C++ will look at this and see, it's a function that takes in an integer and gives me back a Boolean. So I'm going to generate the appropriate type for that, and isPrime will now be a variable containing that function. So here's an example of it in use. We're calculating prime. But I never discussed what the function actually does. It tests to see whether things are prime, very stupidly, just by checking if it's 0 or 1, and then looping from 2 upwards and checking whether or not those values are divisible by the number. And obviously, if it is divisible, then it's not prime because it's got a factor that's not 1 or 0. Not 0, but a factor that's not 1 or itself. Okay, I've heard a question. I'm just going to take a peek and see. No, lambdas can have any type you want. They're fully fledged functions. So my example just happens to use Boolean, but they can take in doubles, strings, they can do arrays, whatever you want. They're completely regular functions in every sense of the term. However, maybe I'm not sure if you meant that, but there's actually an interesting point. They're very often used to create what we call predicate functions or filters, which is where you have a very short function to test a condition and see if it's true or false, and then return Boolean. So they actually are in practice used with Booleans a lot. Yes, there will be VPL assignments. I'm not going to add anything to the VPL until after tomorrow's semester test because the stuff that's there is already a bit beyond the scope of the semester test. I'd like people to focus on actually the stuff that's being assessed. But yes, after the semester test, I'll add a bunch of more stuff so that you can practice that, more opportunities to get marks. Remember, the VPL assignments can never bring your mark down. So if you try one and it's not working, and even though you keep evaluating time and time again, you just can't get it right, it's not going to make your average go down. They can only bring your practical average up. That's all. They can't bring it down. So there's no reason not to try using them. All right, so here's us using the lambda, again, weirdly assigning it to a variable. I just wanted to show you that that was possible. And then once it's inside the variable, you can use it like a regular function. So a function in a variable, if that's something you want, this is how you do it. And then it runs. So not very exciting, but it is what it is. So what was the actual type that we hid away with the auto keyword? It's the function type that comes from the functional library. And you can see it's got a weird syntax. You can specify R, P, R, and the parameter list types are actually variables, but they're type variables. You'll learn all about that in the second semester when we do generic programming. But basically, you can create a new instance of this function type, specify what the return type of these functions should be, and what the parameter list should be. So the type that's this isPrime function was assigned by auto would be function of type, returning bool with an int as its input. Let's see, there have been some more questions. Yeah, the VPL is absolutely to boost your marks and replace missing marks for the weekly practical. So it doesn't help, unfortunately, with the semester test 1 and 2 mark components, but it does help with the assignments and class tests mark component that you see in the semester in the learning guide. So if you look at the calculation, there's somewhere around here. We've got the calculation for the mark. Here, goes to and replaces ones that are worse. So the maximum it can bring your mark up to is 10% of your semester. That's the maximum that the class test assignments can, but it doesn't mean that you can help yourself. So does a lambda function have the same effect as, say, for example, int remain? No. So this is calling a function and storing the result of that function inside a variable. That's just using a function. This is actually storing the code, not the code, the logic function inside a variable. That's what you'd use under or a functional type. So if you've got full marks for your practicals, the VPL it's just good practice. So you will never, if you've got 100%, you'll have 100%. you won't lose marks for not VPL assignments, but they're for you to help practice. Where would you use an anonymous function over a normal function? That's an excellent question. You would use it, typically they use it, as I said, for filters. So like let's say you've got something and you want to pass, you've got a list and you want to remove everything from the list that doesn't, oh, my screen just dropped the screen share. That's a bit of a pity. Let's see if it will reshare again. I don't know why that happened, because Blackboard. Can you still hear me? Yeah. Okay, so the percentage is, okay, stop. I'm going to lose all the other questions. So the percentage is maximum 10% of your semester mark, because that's how much the assignments and class tests pool is. So you can't put any more in that. So if you do well for practicals and to VPL, that's up to you. So in that sense, it's optional, but it's strongly, strongly recommended. It's just supplementary. I don't know what your question was. Oh, when are you finishing up with all of the first semester theory? So there's there's this that we need to finish, and then there's fixed length and dynamic arrays. So it'll take maybe a week or two, let's say two to 3 weeks, and then we're done, and then we just do revision. So it probably won't take all that long, but very soon we'll finish up for the first semester theory, and then it's just pure revision. We've almost covered all the stuff you need for the second semester test and exam. Okay. Okay. Oh, I see you asked again, but I've got it now. Yeah, so I stopped adding VPLs to avoid flooding the list with people who are studying and whatnot. So there'll be new ones added after the second semester, not after the first semester. So after tomorrow, more ones will be added. All right. So good question. What was your question? Sorry, I've lost it. Could you just quickly post it again? Ah, there it is. Oh, yeah, where would you use it over a normal function? So for filtering is a very common circumstance. So basically, you'd write a function that takes in a parameter. Let's say, so I'm going to write it so like we've got a void function, and it's going to filter from some collection, maybe to say from an array or something, or maybe only print, let's say, it'll only print the ones that match a certain test. But what's that test going to be? We don't have to hard code the test. So we write the test as a function type, bool with, let's say, integer as its input, just like we did there. Call it, say, fn test. Then we'll take in our array, say, int of int ARY values of size, whatever. At the moment, we're just working with arrays, or it could be a string. I suppose it could be done with a string, it's fine. And then inside your code, you do something like you loop over the array. And then you use this filter. So you call it a filter because that's what it is. But at the moment, we're just doing it for printing. So if filter of ARY, ARY values at position I. If it passes the test, what's the test? We don't know. Then we print it, let's say. So now I've got a reusable function that will print things under certain conditions. But we don't have to specify what those conditions are in advance. Then later on, inside main or something like that, someone's using this function, is using our function, and they've got an array, let's call the array A. They want to do the filter prints. They do filter print, but they don't have to write a whole separate function for testing, let's say, for odd numbers. So instead, they just quickly throw in a lambda, And they just test it by saying return n mod to not equal to 0. And now this thing will test where the functions are, will print only those things that are odd inside array A. But someone could easily have replaced this with a test for prime, or a test for even, or a test for divisible by 5, or a test for any other property that could be tested where an integer goes in and a Boolean goes out. So this filtering is a very common use for a lambda, and they typically will be super short so that there's no point in giving them a whole separate function. So that's their main usage. Yeah, that's fine. I think this has been answered several times. Oh, that was before the thing. It's drifted. All right. Okay. So this is basically just the syntax from the the trailing type, array, the trailing type function syntax, which says that the type is coming afterwards. So when you write functions in that syntax, if you write functions in that syntax, the arrow just says the type is coming afterwards. So you can see it there in use with the Boolean. It just says the type comes next. So it has no specific syntax. It doesn't mean minus and like less than or anything like that. It just means it's an arrow for the trailing type syntax. Okay, we haven't discussed vectors yet. We'll do that in the tutorials coming up. But they're a collection of anything. So if you think of a string as being a collection of characters, a vector is a collection of whatevers. It's kind of better than an array, really. In real programming, in production programming, you use vectors everywhere, and arrays almost never, or like raw arrays almost never. But we force you to use raw arrays so that you learn about the low-level usage. So in this case, you can think of it just like as a collection of integers coming in, a test function, just like I did before, loop through everything, test to see if it passes the test, whatever that test may be, and spit it out. And then likewise, we could now use it by sending through is prime, for example. And here we've got a couple of candidate primes that we may or may not know, that may or may not be prime, and this will print only those ones that pass the test. Oops. All right, so there are a couple of differences between lambdas and regular functions. You don't have to provide the parameter list if there aren't any parameters. So technically, this is the shortest possible lambda expression. It's just open and close square brackets, open and close curly braces. So it's a void lambda function with no body that takes in no parameters and returns nothing. So it's useless, but that's what it is. You technically don't have to specify the return type. It can be worked out automatically by C++'s type inference. This is something that was added in later versions of the standard. So if you've got an older compiler that does support maybe lambdas a bit, that may or may not work depending on how good the support is. So for any compiler that supports, let's say, C+14 onwards, it should work fine. And they've even added it now in 20, I think, for regular functions as well. But that support is very, very new. The version of CodeBlocks, of C++ that comes with CodeBlocks doesn't support it. Then the capture lists can also be controlled a bit. So if you specify nothing inside the capture list, then it's got no access to local variables. If you specify an ampersand, it says that it can change local variables. If you specify an equals, it says it can only read local variables. So it can't change them, but it can read their values. Or you could specifically list the variables you want, but that by default will be read access. Or you can specify, I want the default to be read and write, but these specific ones should be just value. Or you could say, I want the default to be read access, and the other ones should be by reference. So typically people will either specify nothing, reference, or read. They typically won't give individual lists of variables, because if they did that, then they may as well have just made a parameter list. So this is not actually used that much in practice. These three are the most common. So here's just an example of getting read access. So there's a local variable x, but the lambda can read x as if it were inside that function. There's no x inside the lambda function being defined, but because it's a local variable, it can reach outside of the function and read it. We said it was a read value with that equal. So don't change it, but it can read it. Here's just a random function that generates a lambda version of the random number generator, but you can see it's reading in its values for the minimum and maximum as local variables rather than parameters. And here's a much more complicated one where y is given as a reference, so it can be changed, but min and max shouldn't be changeable. They are simply for reading. So if I called randomize y, it will change the value of y sort of magically. It will reach outside the function and change it. So that's a reason why some people don't like this style of programming, because it actually makes it a bit more difficult to reason about what's changing and what's not changing. So I actually avoid it pretty much altogether. I almost always never use captures except maybe for read-only captures. I almost never do modifiable, mutable captures because it makes your code much harder to reason about. Because here I'm calling a function, I've nicely named it randomize y, and then the variable y will change, but I don't see y being assigned anywhere. I don't see y as a parameter. I don't see y anywhere in this context except by virtue of the fact that I happen to name the variable, the function randomize y. What if it had been called something completely different? Then to see that there's a change in y, I have to look for the actual input. Oh, there it is. And then see, oh, wait, that's a reference. Oh, it actually changes y. Oh, that can change. So it makes it much more complicated to reason about. So I typically don't use mutable captures. Okay, there have been a couple of questions. So I'm just going to go and take a look what's been going on since. Yep, the TUT that's coming out tomorrow. So remember that TUT doesn't require your presence. It's simply a pre-recorded tutorial, and the live versions will be the other versions of that tutorial during the week, and that will definitely work with fixed length arrays. You've already got a video working with arrays, the pre-recorded one from last week during the recess, but we will work with arrays in the tutorial, absolutely. A question will never force you to use C++11, so you can answer the semester test and the exam with only the traditional C++ stuff. It's a permanent change. So the question is that a temporary or a permanent change? It's permanent. So yeah, the person who answered is absolutely correct. That's also why it's dangerous, you see. That's why I tend not to do it. Okay, so that's the end of that. So that last bit, these lambdas, they're optional. They will be worth some bonus marks in the semester test semester test 2 and exam. You'll never be forced to use them in those tests. All right, but let's move on and start with the next set of content because we do have a little bit of time. It would be a waste not to use it. So this, as you could no doubt see, and as you could tell from last week's tutorial lecture, that obviously we're going to be working with arrays now. So arrays are linear sequences of values. You've worked with strings and things. Arrays are like that, except generalized to any kind of value, and they're more like the string literals in the sense that their sizes don't change at first. We'll look at how to make their sizes change, obviously, after this. So at the moment, we're looking at arrays whose size always stays the same. So you'll learn about arrays, how to get data in and out, how to index them. And the one thing people often hate about C++ is how loose it is in handling people's mistakes when they ask for things that are either before the array begins or after the array has ended, what they call out of bounds access. You'll look at some of the restrictions on arrays, and you'll look at passing arrays as parameters to a function. And just for what it's worth, the rule of thumb with the arrays is arrays can automatically be converted by the compiler into memory locations. So the term is decaying into a memory location. We'll look at memory locations more in depth when we look at dynamic arrays, the ones that can be resized. There's a special type in C and C++ called a pointer that deals with variables that store memory addresses. But the important consequence of a memory address and an array being sort of interchangeable, so the array variable itself is actually just the place in memory, the memory address of where the first element in the array is, with the assumption that everything after that first element occurs straight after it, is what we call contiguous. And the consequence of that is that you can always change the contents of an array unless you mark it as a const array, even if you passed it by value rather than by reference. And we'll look at working operations on arrays such as searching and so on. We'll see that the string literals that you've worked with, things like the literal hello world that you output in a hello world program, are actually arrays under the hood. They're character arrays that end in a special character, that character being the null character we saw from the beginning of the ASCII table. Those were the original ways that strings worked in the C language, and then C++ added the proper string data type. So we now talk about those old style strings as C strings and work with them. They're just arrays of characters, really, so there's nothing magical about them. Then what you can do is, if you've got multiple facts that you need to store about one entity, you can use a bunch of one-dimensional arrays to store those facts. But that's a bit awkward and a bit messy. We'll look at a much neater way of storing multiple different facts about a single entity soon. But then we can also see that instead of having a whole bunch of one-dimensional arrays, you could actually have data grouped into two-dimensional arrays. And then you can extend that idea to as many dimensions as you need. So what do I mean by dimension? I don't mean something that Rick and Morty would travel to in one of their adventures. I mean basically the numbers that you need to specify a particular value. So a dimension in that sense is the number of numbers you need to get a specific value. So let's take a look at an example for that. So if you look at a string is one-dimensional. Because to get a value from a string, let's say the string was called f, I need to specify one number. It's a one-dimensional thing. But if I wanted to specify, if I had a two-dimensional collection of characters, for example, I need to specify two values, whatever those values might be, to get one character from it. So the dimension refers to the number of numbers I need to properly index something. Okay, I've got some questions. Okay. How to check if a word contains what? I don't know what the context of that is, but if you're checking to see if a string is hexadecimal, you just need to check to see if it is contains the digits 0 through to 9 and the letters A, B, C, D, E, and F. That's that. So, okay, cool. Let's move on. So, fixed length one-dimensional arrays, simplest case. So in C++ and other programming languages, you have simple data types, which only work on one value at a time, or you have structured data types in which a collection of values is grouped into its own data type. So arrays are the simplest form of structured data. They're basically just a sequence of the same a sequence of values of the same type, one after each other. Ooh, echo. Okay, the syntax for it is basically to give the array a name, and then open brackets, close brackets, and an index to specify a particular value. So that index is a non-negative integer. It doesn't make any sense to have a negative index, because that means give me the value before the first one. There isn't a value before the first one. However, as we will learn, C++ actually doesn't check to see whether your indexes make sense. And what it actually does is it reaches into memory, starting at the memory location specified by the array. So we said that the array name is just the place in memory where the first element is, and then we'll reach backwards or forwards depending on whether the index is positive or negative, and grab whatever it can find in memory at that place and change it or interpret it depending on what you're doing. So you can cause a lot of damage with low-level raw arrays, which is why they're not used much in production programming. They're super dangerous. A lot of bugs are triggered because of them, but you need to learn about them because they're fundamental to your understanding of how the language works. Now, there's a lot of stuff going on in the channels. Let me just take a look. Oh no! Oh, okay, someone else's screen has gone blank. That's fine. As long as some people are seeing it. Yeah, some people seem to be seeing it. So hopefully, I know it's just Blackboard being Blackboard, unfortunately. So let's carry on. So that square brackets is known as the array subscripting operator, or technically just the subscripting operator, because it works on things other than arrays. And the indices for an array always start at 0. And there's a very specific reason for that. And the reason is basically to do with the fact that an array variable is the place in memory where the first thing is. So if you're saying, how many steps away from the first thing do I need to move to get the first thing? The answer is 0. If you want the second thing, then an index of +1 would say move one step forward in memory from the first thing. And that will get you, obviously, the second thing. So that's why indexes always start at 0 in C++, because the array variable itself is where in memory is the first thing. The index says how many steps and in what direction do I need to move from there. So you can look at them like this. This is a very common way of representing them. Subscripts up at the top for the indices, and then the actual values that are stored there drawn in. So here we've created an array of size 10 called list. So these are fixed length arrays. So when you create them, this expression has to be something the compiler knows at compile time. So it can either be a constant, a named constant, a literal constant, like it is over there, the literal 10, or if you want a formula to generate them, it has to be a constant expression. A constant expression formula would work fine, but not something that can only be worked out at runtime. So now, that being said, the C programming language has added an extension to arrays called VLAs, variable length arrays, and that allows you to use a variable instead of an array there. It's not good in the sense that it uses up space on the stack, which is actually quite precious. So C++ decided not to copy that feature. However, G++ is part of the GNU compiler collection, which includes both C and C++ compilers. So by default, it lets you do that because it is a C feature. And unless you turn that off with the compiler flag, it will allow you to use a variable here and everything will work fine, except for the fact that you're increasing the chance of a stack overflow. This is one situation where we don't allow the fact that it's G++ and a default, it works as being a good thing. Don't do that. Don't put a non-constant expression there. It wastes stack space, increases the chance of a crash. Not good. Even if C will let you do it. Okay, but then so on and so forth, so it's fine. There's no operations on a whole array other than writing a function that will do stuff with the array. So if you wanted to combine, let's say, element 3 and element 6 of the array, you'd have to index them, retrieve them, and so on. And you couldn't just add two arrays together by saying array 1 plus array 2. You'd have to write a function that would loop through the two arrays and add everything together and do whatever it is that you want to do with it. So just bear in mind, you work on the components of the array, or if you specify the array variable without indexing it, it refers to the place in memory where the first element is. That's it. So what can we do with a 1D array? We can initialize it. When we initialize it, we get a once-off opportunity to initialize it very neatly using what they call an initializer list. And that's very neat, but you can only do that once. Every other time you work on an array and you need to do something with everything in it, you typically will either have to loop through the array or pass it to a function that does the looping for you. You can input data into the array, output data, find things in the array, biggest, smallest, specific values, whatever you want. Basically any operation that requires you to loop through the array and access all the indices and do stuff. So loops and arrays go together very, very neatly. And as you'll see, the dimensionality of the arrays typically means how many nested loops you're going to have. So a 1D array will just typically have a single loop to process it. A 2D array will have two loops nested inside each other. 3D array, 3, 4, and so on. So the number of dimensions and the number of loops required to process it are tied together. So here's an example. Create an array of size 100, loop through the array, and do stuff to it. In this case, reading from the input stream directly into the array. That'll work fine because Cin will see it's an array of type integers, so it's an integer, and will do the integer conversion thing. Like that. I typically don't write code in this style mostly. I separate my input and output and processing stuff into their own functions, but it is done, so there it is. So the legal indices for a particular array run from 0 inclusive up to and including the size of the array minus 1. If you try and reach outside those bounds, it is logically incorrect, but the compiler is not going to do anything and there's going to be no issues. Maybe max you'll get a warning, but probably not even that. And what's going to happen is your code is going to reach randomly into memory somewhere and change stuff or read stuff, which will at best cause confusion and will, actually let's reverse that. It'll at best crash the program and at worst cause confusion, because crashing the program is actually great. You want to know there's an error. Worst thing that could happen is you read a value that's somewhere randomly in memory. It's got nothing to do with your array. Interpret it as if it were part of the array and then use it. So what if that value you were reading was being interpreted as an interest rate, or was being interpreted as a pass-fail result for a student? That's bad. You don't want some random value being interpreted as a number or a Boolean value or whatever and being used in logic. You'd rather have the program crash. But the thing is, C++ is only going to crash the program if that memory wasn't allocated. If the memory was allocated to something else, it's going to just let you touch it and do whatever you want. But if it's unallocated memory, the whole program will crash, which is actually a good thing. So most programming languages after C++ have added better bounds checking for their arrays. But in C++, as I said, for production code, you typically don't use arrays anyway. You'll use something like vectors or some other container. Okay, we're about done. So if there are any questions, I think we'll continue from that on Tuesday, on Wednesday. And I think I'm going to answer these questions